Welcome to the Cumulocity Release 8 Simplifying Mass Customized IoT Solution Platform Deployment webinar for device developers. I'm Philip Hooker, Director of Strategic Programs at Cumulocity, and I'm delighted to be joined today by Stefan Valent, Cumulocity's Chief Technology Officer. With organizations adopting the Internet of Things at an increasing pace to digitize their organizations, pioneering organizations are realizing the pace of development of their IT solutions need to at least match their customers' demand for consumerized services. In this environment, conventional, long-duration, resource-heavy project-based approaches are rarely suitable, as they often slow an organization's innovation processes and create the threat of in-flight market disruption. Alternative approaches which leverage efficient product-based technologies and minimize product resources in preference for as-a-service capabilities are required. Cumulocity strives to make development and operation of IT solutions simple to ensure that their efficient adoption can be done for practical real-world situations. Our recent release of our leading IoT platform radically simplifies the mass deployment of consumerized IoT solutions for service providers, enterprises, and OEMs in all market sectors. Firstly, I'd like to provide a brief introduction to Cumulocity. Cumulocity was born in an innovation initiative inside Nokia, focused on making carrier-grade network management systems applicable to the requirements and economics of the evolving machine-to-machine market. The organization grew rapidly through its successes, won numerous industry awards before being spun off but still backed in Nokia's 2012 reorganization. Today, Cumulocity serves over 100 enterprise customers using over 1,000 tenants and supports over 3,000 developers around the world. Our recent acquisition by Software AG, one of the world's largest integration and digital transformation solution providers, allows us to accelerate our growth globally and leverage their digital business platform to bring even greater value to customers. Cumulocity strives to remove the complexity and cost from IoT and allow the benefits to be exploited rapidly, comprehensively, and securely by all organizations. We offer a fully featured Internet of Things platform product which covers 80 to 90% of the requirements of most customers out of the box. The remaining 10 to 20% can be easily developed using our open APIs, plugins, and application integration. Our IoT platform is inherently carrier-grade for security, reliability, and availability, and is both device and network agnostic. It can be deployed across over 160 global cloud hubs, on-premise, on-site, or as a multi-layered hybrid. At Cumulocity, we feel that the Internet of Things is all about partners, and Cumulocity is continuously leveraging and building out its leading partner network. As a horizontal platform provider, we're involved in many vertical markets and continuously bring the ingenious, innovative approaches from one market to the other markets we're working in. Our IoT platform is white-labeled by many partners around the world. We have the devices from many manufacturers pre-integrated and open-source agents for the most common device platforms. Our breadth of network, application, systems integrator, and independent software vendor partnerships helps us solve the customer's common problem, enterprise digitalization. So, we mentioned something about Release 8. So what is Release 8 and what benefits does it bring? Before we talk about capabilities, it's useful to clarify Cumulocity's development approach. Cumulocity is extremely customer-orientated and believes the way to deliver the greatest value in an evolving environment, such as IoT, is to adopt a hyper-efficient agile approach. In this way, Cumulocity continuously evolves the IoT platform with new releases available every 2 weeks. In a continuously evolving environment, such as this, the major releases like Release 8 become snapshots of the overall platform capability at that moment in time. As previously mentioned, Cumulocity's key focus is to make IoT simple and the benefits be attainable by all organizations. Release 8 consolidates a number of capabilities which simplify the deployment and operation of mass customized IoT platforms in management speak. The Enterprise Edition virtualizes bespoke IT platforms, and removes the need for a separate IT platform instance, which significantly reduces operations and maintenance issues. Cloud remote access lets customers directly interact with the human-machine interface of end assets in a secure manner from within the IT platform user interface. The Smart REST editor provides drag-and-drop device data mapping and further simplifies device integration. The new device simulator allows additional representation of devices and assets to be created and run against business rules to prove their operation prior to deployment. The service status provides a snapshot health check of the platform and its components for operations staff. Our Cloud Center app provides sales executives with a way to animate the platform for the most hastily organized sales demo. As Release 8 is one stage in the continuous evolution of the IT platform, it is fully backwardly compatible with every other version and all the applications built on them. We will introduce and demo a couple of these features which are relevant for the device developer in this webinar. As this webinar is predominantly regarding sort of technical integration, we've taken very much a hands-on approach. This approach is very similar to what we do in our regular public training sessions. For more information about these training sessions, please go to cumulocity.com/training as indicated at the top here. So, there are many IoT devices already deployed, many in development, many already pre-integrated to Cumulocity, and many more new devices currently being connected. So how can you connect new devices to Cumulocity? I'd like to hand over to Stefan here.
Oh. Yeah, thanks, Phil, for the introduction. So let's have a look on how we can integrate new devices and what is new in Release 8 in that respect. So if you look technically on integration of devices and machines into Cumulocity, then we have two approaches. On the left-hand side, you see the plug-and-play approach, where you, without any development, just by using partner gateways and partner hardware, you can integrate existing protocols, especially field bus protocols and industrial protocols into Cumulocity. And that works by either using a hardware gateway, for example, from Netcom Wireless, Dell, or industrialized Raspberry Pis, and you put Cumulocity agent on it, and then you get support from Modbus, CAN bus, OPC UA, and similar protocols, and you can more or less in 10 minutes connect these field bus protocols to Cumulocity without coding. Alternative, you can take partner gateways or also so-called data loggers, and for example, from companies like Insys, Option CloudGate, Redline, or Libelium, and again connect these to Cumulocity and support even more, up to 300 different protocols. Again, in a codeless way, just by configuring this gateway. Now, in case you want to connect your own device or you have a new greenfield development, how do you connect these devices to Cumulocity? For that, we propose an approach to use the device SDK for HTTP, which provides you with all the protocols and also open source software to put on your device in order to connect to Cumulocity. Now, with Release 8, what we introduce is a new additional SDK for MQTT. So while it was possible already in the past to support MQTT, we have now improved MQTT support, and it's natively supported inside Cumulocity. And there's a huge number of documentation available, also open source agents, and also additional tooling, and that will be the subject for today's webinar. So before going into the Cumulocity features, let's first have a look on what is MQTT and why have we selected it among all the protocols that we supported as a second built-in protocol, which is natively supported in the core of Cumulocity. So MQTT was developed from the beginning as an IoT protocol, and it's an open protocol, so which means you can easily access the specification. It is developed as a standard in Oasis, and Cumulocity is a member of Oasis and member of the specification group, and currently the group is working on the next version of MQTT, version 5. Then MQTT is very lightweight, so the traffic overhead of MQTT is drastically lower than, for example, for HTTP, and you will see some more detailed numbers on that in the next slides. Additionally, also it's easier for clients to support it, so the client code is also slightly smaller than for HTTP. Reliability is very important in IoT, so especially if we talk about rolling out configuration changes to devices and securely transmitting data in a reliable way. And MQTT has built-in quality of service modes, which really ensures that the device and the cloud can reliably exchange operations and information. Then one nice stuff about MQTT is it's really very simple, and surprisingly, it's even simpler than HTTP. So if you are HTTP expert, you are surprised that sometimes there are more options than you think in HTTP, for example, to send responses. And that's not the case for MQTT. So, for example, to receive a response from the cloud, there's no option in that. It's simply one way how to do it, in contrast to HTTP, where you have multiple ways to deal with that. And we had in the past sometimes problems with certain embedded devices that haven't implemented all options, and then that kills interoperability. So very easy, clear protocol. And of course, all the technical advantages are good, but not sufficient if we talk about adoption, because is it really accepted by the market? And when we started in 2010, it wasn't that visible. But nowadays it has get really market adoption, and as you can see from the Google Trends curve on the bottom, it's really now universally accepted as a standard protocol by many companies. So that's why it is now in release 8 natively supported. But we went a step further. We not only implemented MQTT, we also put a lot of effort, for example, into the traffic size and in other advantages. So let's have a look in more details on comparison between MQTT and HTTP. So from a protocol viewpoint, it is located on a similar level. So both protocols use TLS for security, for encryption, and for providing safety against man-of-the-middle attacks. And both protocols are also similar in that they don't mandate a certain payload. So the data that you transfer, both in HTTP and MQTT, it's not defined by these standards. An advantage of MQTT is that in contrast to HTTP, the authentication of the device is done only once, whereas in HTTP it's done in every request. From a security aspect, that is equivalent, but from a traffic viewpoint, that causes additional traffic, which of course we want to avoid. So MQTT is better in that respect from a traffic viewpoint. Then if you send data to the cloud from a device, even ignoring the data, there's a certain overhead from the protocol in terms of the protocol header. And in HTTP, even so we took a lot of effort in optimizing that, it's still around 280 bytes. So in other implementations, it can be even much more, but in Cumulocity, it's 280 bytes. But with MQTT, it's even is drastically reduced. The complete header is 8 bytes, where 4 bytes are defined by the MQTT standard and 4 bytes are defined by the very small Cumulocity topic name. Then in HTTP, we typically have two TCP connections. Why two? Because IoT is about bidirectional communication, about from devices to clouds. So you want to send sensor data, and you also want to receive from a device viewpoint operations like software management operations or reconfiguration operation, or you want to change the state of the connected industrial machine. So in HTTP, to do that, by default, you need two connections. And that causes sometimes problems for very small embedded devices, which are very resource limited. And that's now easier with MQTT because it's from day one designed in a way that you have one TCP connection and you have bidirectional communication over that connection. So there are also some small areas where MQTT needs to improve. So with HTTP, you have a very easy way to do request response messages. So for example, if you have a gateway that has a topology, a local, let's say, Z-wave topology to be managed, typically our gateways synchronize the topology that they see with the cloud stored topology, and for that they request the current cloud topology in order to synchronize that. So this is out of the box with MQTT not possible, so we needed to put some own code on top of that. But luckily in version 5, this is now also put to the standard. So with version 5, you have a standard way how to do request response. And then finally, for deployments, they use fixed network connectivity. HTTP is very nice to go out from an enterprise into the cloud because most enterprise firewalls allow outbound HTTP traffic, whereas with native MQTT traffic, you might run into problems. But that's can be prevented, these problems, by using WebSocket communication, which is also supported by Cumulocity. So on top of that, on top of these many advantages of MQTT, Cumulocity provides specific advantages with Cumulocity implementation of MQTT. So, as can be seen from previous slides, we put a lot of effort in achieving plug and play of devices into the cloud environments. So one typical scenario is that you just pick a sensor from the warehouse and you ship it to any customer, and the sensor, as it is shipped, doesn't know to which customer it belongs. So in order to support that, MQTT implementation of Cumulocity supports multi-tenancy, so the device only needs to connect to one endpoint, but technically then it can be paired to, in the registration process, it can be paired with a specific tenant in the endpoint. So that's especially interesting if you are a service provider and you ship your devices to different customers. You can simply pick any device from the warehouse without personalizing it for the customer. So the personalization is done when the customer takes the device into use.
Stefan, is that often called zero-touch provisioning or something similar?
Yeah, exactly. So from an enterprise viewpoint, the one that ships the sensors, there's no need to touch the device at all. And also the one who installs the device doesn't need to have hands-on configurations on the device. Everything is done via the cloud. And then still with MQTT, the existing principles of Cumulocity are followed, which are that you can simply connect any device to any Cumulocity cloud, so either cumulocity.com or any cloud of our partners from any mobile operators. And there's no need to first configure a model into the cloud. Instead, devices are self-describing. You just connect them and they work. And that's possible because we have predefined data models and payload formats that the devices use. And we will see that also then in a few minutes in the demo. So we took also effort in really minimizing the traffic on top of already the traffic minimization that MQTT provides. So we made sure that the topic names, for example, are very short. So the standard topic name where you post data is S for Smart Rest, and then /US, which is U for uplink, and S for standard data models. Then also the payload format, we took effort to minimize that. So we decided to go for CSV, which some of you might know already from HTTP. So the name is Smart Rest, but it's a CSV format. And for example, to send battery information to the cloud, you use 212 as identification for battery information, and then send 95 for the 95% battery level. Of course, there's no metadata included here, so you cannot see that from just reading the CSV, that this is a battery level, but that's exactly the purpose of that, because saving bytes is really essential for our customers. So we have customers that connect millions of devices, and saving bytes there is really a cost saver. And then in many discussions, one of the first questions we run into is customer asking us, okay, which MQTT broker are you using? And the answer is that we don't use any standard broker, MQTT broker out of the box. And that's done intentionally because if you do it in the wrong way, you open up quite many security problems. So you might have read from recent MQTT IoT security problems where 15,000 devices on the internet could be attacked. And one reason for these attacks is that you can subscribe as a device for all topics using the hash sign, which means that if an attacker grabs one device and is able to go into this device, he could also attack all other devices if you use a, let's say, naive MQTT broker approach. And that's why we don't have a normal MQTT broker. Instead, we really have an implementation where we implement the protocol and we ensure that no device can intercept the traffic of other devices. So after this introduction, let's have a demo. And what we will do is we assume we have a sensor, and I simulate the sensor with an MQTT client so that we can see what actually is sent. And what we do is we create the device and then we publish the battery level to the Cumulocity. And let's switch to the demo. So what we see here on the left side is an MQTT client, which is web-based from HiveMQ, which is very easy to use. So you don't need to install anything. You just go to HiveMQ demos WebSocket client. And on the right side, we see Cumulocity. Now, what is needed to connect to this tenant in Cumulocity? So the tenant is called Stefan Test. So what you do is you connect to the complete Cumulocity installation by entering mqtt.cumulocity.com. Use the client ID. The client ID must be unique. And as username and password in this demo, I used a manually created username. Of course, later, as we will see in the next slide, typically this is done automatically with self-registration. We will see how that works later. And then I connect, so I'm connected here already. So the MQTT TCP connection is established to the cloud. And now I can publish data to this tenant for this specific device. And the first thing the device should do, of course, is to create itself. And that message is done with the number 100. So if you wonder where all these numbers are coming from and where you can read about these, so there is obviously in the online documentation on cumulocity.com, you have now a new section about MQTT developer guides. And there's one section, MQTT static templates. And here you can find all the predefined message numbers and formats. And 100 is a device creation. So I press now publish, and not too strong. And then I reload the page, and now my device has been created. And if I click on it, I get a first overview about the device. So up to now, we haven't sent any battery data. So that's why you don't see here a tab for measurements, because the device currently doesn't know that it does have a battery information. So let's the battery, and we publish that. We sent a few values to make the data more interesting. And now, if I refresh, you see that the measurement tab is now visible because the cloud has detected, okay, this device does have sensor data, and it automatically shows here that it's battery data. And now we can visualize this battery data also in real time. Now we could, for example, also show if I publish additional data, it's immediately shown on the right-hand side. So I can, for example, simulate here some battery going down to 50, and then maybe to 0. So you can see that on the right-hand side. So of course, you can also extend that to other sensors. So I could say we have a temperature sensor, which would show 5 degrees. It's very cold today here. So we push that. And again, if I refresh this, Cumulocity has detected that there's now also a temperature measurement and shows the values. So that's how it works. As you can see, it's very easy to use with MQTT, and it's also very minimal data that we send. So only a few bytes, and you have a lot of data already in Cumulocity. So let's have if you look at the data overhead, and as you could see, we took a lot of effort in minimizing the data load. As a summary, compared to a JSON over HTTP approach, the MQTT data gets you to 7% of the original already optimized HTTP data. So it's a massive reduction, and a reason for the reduction are the small header, including the small topic size. We also reduced even the CSV data. We reduced a little bit by avoiding the sending IDs for the devices. The response is much smaller. That's an MQTT feature, and so in total you end up with 7% reduction in this example of sending a single sensor value.
So, Stefan, this is an incredible reduction in data being sent, and so obviously this vastly improves the business case for some sort of remote monitoring cases. Has it changed some of the cases we've worked on?
Yeah. So for customers that do use mobile communication, not all customers are using that, but for those customers that do use mobile communication, that have a huge number of devices in the field, so that's also a very welcome change, because as you can you can do the math yourself by multiplying that with all the packages that are exchanged for one device, and then also over multiplying it with the number of devices gets you a huge reduction in the traffic. Yeah. But then on maybe a little bit word of warning. So there's a small note on the bottom. So this is only the data on top of TLS, TCP, IP. And so especially the TLS traffic is also a large amount of the overall data. And even we put a lot of effort there, the TLS data still has to be added on top of that. Okay, so let's again look at the device and what the device needs to do if it connects via MQTT to Cumulocity. So what you see here is a diagram of the steps that are executed on the device when it's powered on. So on the right side, the start symbol indicates the device is powered on, and this would be a device that just comes out of the warehouse, so that is not yet personalized. What is happening inside that device? So what do you as a developer have to implement? And in case you want to support this plug and play and registration mechanism, the first step is that you need to get access to the Cumulocity cloud by receiving the credentials. So that is a documented first step. And this is called tenant pairing and secure credentials deployment. And for that, there's a specific feature in the MQTT implementation. So you subscribe to a certain topic in order to receive that. And there is more information about the device integration chapter in the documentation. So if you go here to documentation, there's one chapter, device integration, and that explains, that gives a lot of details about this different steps. Then we have an optional step where in case you deal with child devices, so child devices will represent the local Z-Wave, Bluetooth, Modbus, or whatever topology that the gateway is managing. In case you have a gateway, you need to deal with so-called child devices, and that is also supported out of the box with the MQTT protocol. So you can have predefined formats where you can simply create a child by just giving the name, for example. So that's a drastically improvement compared to the HTTP way, where you need to have a little bit more complex communication with the cloud. And then in the end, the device enters a so-called, typically called main loop. So it does what it needs to do, for example, collecting data from Modbus devices and concurrently receiving operations. And also there is an improvement. So in MQTT, you do not need to deal with IDs of devices or, for example, alarms. So we have removed much of the ID handling. And instead, for example, for alarms, it's sufficient to cancel an alarm if you just provide the alarm type. Whereas in HTTP, what you had to do was when you created the alarm, you had to store locally in the device the alarm ID and then use this alarm ID if you canceled the alarm. So much more easier, and the device developers inside Cumulocity and also from our partners we're very happy with all these improvements because it really makes development much easier. So you get more information from the website. So the website also includes examples for different languages. So if we have examples in C, Java, JavaScript, and Python. And if you look at the examples, I think you can also see how easy it is in programming, on the programming language level, to connect a device to Cumulocity using MQTT, because most examples really fit on one page. So that's a very easy starting point. Just copy paste the code and start working from this place. In case you want to get already a lot of code for device management and for other features, you don't need to start from scratch or from this example that I've shown. Instead, you can use Cumulocity Agent, which is available as open source in Bitbucket. And if you have questions, do not hesitate to ask questions on Stack Overflow. We recommend that you tag it with Cumulocity, and then you should get a fast answer. So you might have wondered in the past, okay, I can now send battery levels and I can send temperatures, but how do I deal with my own specific data? So how can I create new device data definitions? And so how can I go beyond these predefined ones? And there's now a new feature which is called Smart REST Editor, where you have an interactive user interface to do that. So in the past, you were doing that just using certain API calls, but now there's a user interface for that. And let's first look at the high level. So if you want to have your own CSV formats, so beyond the ones that are built in, you use this Smart REST template editor I will show in a second. And then you define your own data format. And then after you've done that, you can publish to a new topic, which is S for Smart REST, and then U for uplink or upstream, and now not S for standard, but C for custom. And then you provide the ID of your templates that you have created. So as an example, you want to send pressure and pressure information. Let's say you have a compressor and you want to compressor deals with pressure. You want to monitor that, and you want to send it in a minimal way. You decide that it gets message number 600, and the templates are you store them under com.acme, and you do that in the Smart REST template editor. We will do that in a second, and afterwards we publish to the subject the payload 600 and then the value 5.1 bar, for example. So let's do that. We go to device management. There's now a new entry called Smart REST template. So as you can see, there's no custom template defined yet. So we want to create a new one. So we call, let's say we call it template for Acme, and the ID that is then used in the topic is from Acme. And this creates now an empty template. And then I add a new message to that. So the message ID was, we said was 600. We can give some textual description, which is just for information purposes. And what we want to do is we want to send a measurement. We talked here about pressure. And what we have to send is then also Acme pressure value as a number. And now I save that, and now I have defined a new more or less CSV format. And what we added here is some preview of the CSV, and that helps you to understand what you have to send then in the end. So you can see here that what the system is expecting is 600 comma and then a time and then a pressure value. So let's go back, let's try it out. Let's go back to the device. So we are back here to our device where we had already created battery and temperature. If I go to the MQTT client on the right-hand side, it's still connected, so that's good. And as we learned now, I sent to a different topic, so which is with C for custom, and I use the ID that I have entered. And now I use the message number 600. And I'm lazy, so I can avoid the time by just leaving it empty. And I give the pressure 5. So I publish that. Again, I publish a few values here. And now if I refresh that, I can see that the first, there's an additional sensor, which is called Acme pressure, and it shows respective data. So we could do the same also with real time. So we see here the data that was just posted to that topic. And of course, this is just the default visualization in device management. Of course, you can create dashboards and analytics rules for exactly for all this data. But I think that's subject to a different webinar. So that's in Cockpit, of course, you have much more, in the Cockpit application, you have much more functionality to deal with that data. But that is then not related to NPTT. So if we look on the role of the editor, so when do you use this editor? So in our experience, the developers, our developers and customer developers use it in the beginning of the development process. So you define the CSV formats using the SmartRest template editor, and then you do some first tests with the devices. But then in the end, what you do is you use the developed templates and put them on the device. So the same functionality that you execute when using the template editor is also available via APIs and also via MQTT. So you can also create the templates via MQTT, and that's actually what we recommend in the end, because we want that the devices are completely self-describing and that you can connect the device to any tenant in the world of Cumulocity partners. And for that, then as a step, you should put the templates into the device and publish the templates to a special topic, which is S/UT, T for template. And then what you get in the end is really a fully plug-and-play device that works with any Cumulocity installation in the world. So also with any partner in India, China, Australia, Japan, in Europe, and so on, because the device contains the template. So that's about the SmartRest template editor, and the templates that you have created can also be used in a different context. That is in the context of simulating the device. And for that, I hand over back to Phil.
Excellent. Thanks, Stefan. Thanks for the great demos and run through. So hopefully you can see my screen. So as Stefan said, we've shown how we can integrate completely new devices, and also how we can actually define some custom data definitions for those devices in the general product development process for the devices themselves. So now, slightly approaching the development side from a different angle. There are a number of ways that Cumulocity can actually help the overall IoT solution to be accelerated, and let's discuss sort of one of those. So, IoT solution development requires activity in at least 4 areas from our experience so far. So, product development, consisting primarily of business case development, product marketing, and also go-to-market activities. Cloud development with online server-side business analysis, design, development, and deployment. So everything online to provide this wrapper. The embedded development, which is never to be underestimated. So kind of detailed hardware development, software, kind of embedded software development, maybe kind of firmware development, kind of integration, and also productization. And also kind of operations. So all the kind of the back-end infrastructure required to make this work, kind of ordering, billing, sourcing, and other activities for a service to be efficiently deployed. What we've found is most solution developers encounter a common problem when embarking on their IoT journey. This being that there's a necessity to repeatedly test the interworking between the cloud and embedded developments, or the development tranches, and this often becomes the key determinant in the overall development time, and also often limits market responsiveness. So decoupling a large proportion of these development interactions between these 2 tranches with simulators and test harnesses allows both progress at a faster rate, and also the ability to shorten the overall development cycle, and also increase in market responsiveness, as well as allowing solution development to progress in all areas in parallel. So whether that be kind of functional development or use case or user experience design, performance optimization for the overall system, both the cloud or online service plus also the embedded device, and also for mass scale. Compatibility, so for mobile devices and also other tablets, and also industrial HMIs. Security framework design, and also kind of operations management development. So allowing everything to kind of work in a controlled way in parallel. In Cumulocity, all aspects of a device can be simulated. The new device simulator in Release 8 provides an improved way for simulated devices to be used. So firmware, software, and configuration settings can be sent to simulated devices. Operational commands can be received and accepted by the simulated device. Playlists of messages and delays can be created as shadows of real-life device operation. Both predefined and user-defined measurement alarms events and inventory messages can be sent, as sort of Stefan indicated before. And also multiple instances of the same simulator can be used for advanced testing. And now, as always, let's move to the demo to show how this can work. So within the Cumulocity device management application, we now have a simulators tab. In this tab, we can actually create our new devices. So we'll just create an empty simulator just to show you how this can work. Call this sim device. And we now have an instance that's paused and not currently running. If we click, can either click on it or actually click to edit. We have our playlist here. We can sort of fill out. It currently has a sleep message kind of predefined. And to this, we can actually add our commands to be sent to Cumulocity. So if I add a message here, and we can actually select from a number of predefined smart REST templates. So these essentially are all the smart REST templates that Stefan previously indicated. So if we quickly look at the REST guide, we have all the static templates available that are detailed here, plus also any other templates that yourselves can actually add into this. So for this demo, let's actually let's quickly add in the set required availability interval, just for the device to tell the platform that it's going to be sending data. Other common ones we could actually add here regard the signal strength. So we can actually just send this. So let's say the RSSI value is minus 75 dB, and also the BER is 37%. What we might want to add as well is information regarding the battery level. So taking on from sort of Stefan's previous example, so actually add in here battery level, and let's put a couple in. So let's say 50. Let's say 25. And let's say 5. And now, as the simulator goes through, it's actually going to play through all of these messages. So you can actually add a couple of sleep messages here, just to actually fill in the gaps. There's actually intervals between the data being sent. So I'm going to just move this one down. So move this one down to here, and put these other sleep messages in. What I might do is actually create one more than I need, so just delete this one. And also recognize we probably want to add in maybe a location as well. So consider this might be some sort of a login type scenario. Let's add in a location. And an interesting place to look at, we'll see this on the map later, is this location. Let's quickly type it in, so 1 second. So we've created our playlist. We can also select operations that can be accepted by the simulator. So we have some predefined operations here, and we also add some custom operations. For this demo, I'll just actually click on the restart. So now we've actually set up our simulator. So if we go back to the definition tab, we actually see it's paused. There's one instance, and it's got 9 messages or 9 instructions in its playlist. If we now click for it to be run, we can then quickly search for this in our device management list, and we can see both that it's actually active, so the send request is coming through, plus also the measurements that are actually being sent. So if I just aggregate these back on the last minute, we can see this 50, 25, 5 being sent, but also we can also see the signal strength information coming through. As I indicated, we've got it as we've actually sent the location information. As soon as that's sent, Cumulocity can actually recognize it and populate it. So you can see this location is actually Namche Bazaar, which is sort of very close to Everest. So we actually populated the data. So when we create these simulators, generally they are to test the wider capability of the overall platform. So if we look at a cockpit display, so a dashboard I previously created, so we can see here a number of elements that I've defined, and what I need to do now is just actually add this device to this dashboard to get the data in. So it's now updated in the location, and also assign the data points to these tabs. Just 1 second. Flip the battery level of this one. You can see it's updated, and also I will select the battery level for this one also. So see the live information for the location and also the battery level being displayed here. So we've sort of tested our dashboard. Also, we can actually test our business rules for this. So what we might want to do is just add a smart rule. Add a smart rule for this information. So our measurement thresholds create alarm. So if it's below or above a certain area, we can actually create an alarm. If I just change the name for this to be battery low. And also so we can see on the graph, I'll actually add here a new alarm. New alarm to be shown. So now, as soon as this the battery level goes in these ranges, everything's updated. And also on our graph, we can actually see the alarms actually activated. And once again, as soon as the simulated information shows that the battery level is outside of this, all of the displays here, so the map and also the alarm list, can actually indicate that's valid, and also the level of that criticality with the indications shown here. So we can actually quickly sort of show device demos in that way. What we can also do is look at this from a positioning perspective, because obviously we can create tracking services. So Cumulocity has a number of preset simulators. So for temperature measurements, but also kind of position updates. If I select this position update one, we can actually create a new simulator just actually showing the position updates. If I click on this, I'm going to show you what's in here. So we now have a far larger playlist with numerous position updates, providing a trace of where this device would be. So if I now play this position update, what I can then see, going back to our cockpit application, just to show the dashboards. So I'll just find this device once again. So I click to show the trace. So I can now see this simulator, the simulator trace going around the lovely city of Düsseldorf, just going around to actually pick that up. So as well as, and then obviously we can actually put on top of this other business rules, other dashboards, other capability to show how things work. Each of these simulators, there can be numerous instances of. I think, as you can see here, so we have one instance of both of these. We can actually add up to 10 to show how this works, etc. So I think that pretty much concludes this kind of quick demo of the simulator. If I just pause this and then go back. So at this point in time, I'd now like to leave it open to have any initial questions. So if you like to post those in as chat, Stefan and I would spend the next couple of minutes just to answer those for you. So if you just sort of type any questions into the chat now. So whilst waiting for these questions to come through chat, so Stefan, there's always one that's sort of top of mind with me, and also it's becoming kind of more commonly discussed at the moment. So that's regarding kind of integrating kind of low power WAN devices. So we've discussed kind of the MQTT broker, the smart REST capability. How can both of these be used for low power WAN, and how does that work?
Yeah, that's in fact the case. So, for example, the Actility LoRa integration that we have that can natively deal with exactly the smart REST templates and the CSV format that we have presented. So more or less that's fully compatible.
Great. So we've got a question here. So would the MQTT broker part of the cloud solution in terms of hosting? I'm not quite sure. I think it's probably asking about would the MQTT protocol recognition be available? And what about supporting custom entity payloads and topics? So I think on the second thing, custom entity payloads and topics, I think we've covered with the smart REST editor. So there's an easy way to integrate that. Stefan, I'm sure you can add some comments there. On the first part, maybe just want to kind of rewrite the question. I think it's a bit hard to understand. I don't know if Stefan, you want to add anything else?
Maybe. So Cumulocity is a native cloud solution. So maybe the question is asking. So in general, every partner of us who has Cumulocity installed will get advantage of the MQTT protocol support once the respective Cumulocity version is installed. So all our partners like Deutsche Telekom, Telstra, Entity, Reliance, and all the others. Sorry if I forgot one. Once they have the release 8 installed, they automatically get the MQTT support for that. So it's MQTT support is built into what we call core. So it's a feature that comes with every Cumulocity. If you want to disable it, obviously you can disable it in the load balancer or by disabling the respective ports outside of Cumulocity. but by default it is enabled and available for all.
Excellent, excellent. So obviously, so Cumulocity is very much kind of open. So obviously, we provide kind of open interfaces, open APIs, etc. All of the capabilities we've actually shown today in terms of the user interface, the user interfaces that we've kind of shown, that they're also available via kind of REST APIs, aren't they, Stefan?
Yeah, exactly. So both, for example, the Smart REST editor features. There's also REST API, which is also documented. And that's following the general pattern of Cumulocity, where all features that we have seen today. So, for example, when you added a device to a certain group manually in Cockpit, of course, that can also be done via REST APIs. So that applies to device management and to Cockpit and also the administration application. So all the REST APIs are documented on the web page in case you want to know more details about what is available.
Excellent, excellent. So I think we don't have any more topics for this, the questions at this moment in time. So just like to say thank you for your attention. Please use the details shown to contact either Stefan or myself. We will send you a link to the online video shortly. And thank you once again, and have a great day.
Thanks a lot from my side. Bye-bye.